Okay, so we have our small mini game made in C, and now we want to add a GUI to it because the terminal UI is not good enough, I guess, for my likings. And um, I would say that we can try to make it in WebAssembly. So yeah, basically the goal for today is to just have um, this game and for each cell display like not pixels but little squares in the browser for to represent each cell. So if we take a look at our code, um, yeah, we have some functions that we can take out from here into, let's say, a library, and then keep the main as the terminal UI part, and then start working on the JavaScript side, and that would be the second executable. Let's call it like that. The second entry point to our game. So yeah, let's see what we can do from here. So basically, uh, I mean, from what I vaguely remember, is that we cannot really have structures like this in WebAssembly. We can use only, um, I guess, like simple arrays or simple variable, simple integers and stuff. So I think that's one thing. I don't remember using structures when I last did it, but again, that was also in Rust. Um, so yeah, I don't know. Let's try to first of all move the stuff to a new file. So let's create tetris.h and tetris.c. So this would be like the library. Tetris h. Let's do the defaults. So first things first. Let's just copy paste the stuff that will be common. So basically this part into here, right? And now what we need, well, actually we can delete this part because we copy pasted. Now the pieces will actually also be inside of the C file. Okay. These are part of the main, basically. And I think this can be part of the H file. So I think we can have them here. Let's hard code the size of the board, I guess. So yeah, now the main will have just a function that prints. So let's include tetris h. Now if you go here, let's copy the enums because these should be part of the header file. Okay, now let's include our header. Interesting. And now we just need to define the header of the functions. Okay. Oh, it was I deleted the endif. Okay. So here we actually have some functions from the libc. These won't be available to us in WASM, but for now let's include string and stdlib for random. So yeah, one sec. Okay, done. So now like we have the basic functions that we can apply on the on our Tetris game. Basically, we init the board, we spawn a new piece, and we tick on the board. So let's go to main and let's try to, let's say, take these two variables and put them into the structure, because it's not that good to have these variables globals. Okay, so if we go into Tetris, we can put them into our structure for now. Okay, now let's go into the C file and let's say the score equals 0, is game over equals 0. So basically now when we have here the score, we can actually say the score is that. Okay, and now in main.c, here we can say t is game over. Well, actually, is game over could have been a global variable, or like, yeah, because it's or like even just is game over, just a variable like this, because it's just for that. And here it, okay, yeah, tetris h, like is game over is just for our main.c file to not to break the loop. So yeah, I think now things should be fine. Let's check. I think there are no more errors. Let's try to use a make file, I guess. Make file, just because, yeah. So let's call this one main, it will depend on main O and tetris O. And how about, because for WASM we are gonna need clang, so let's, I don't know what that is anyway. So for main O, I think that's the stuff that we need to build our game. So if we do make, we should have main and it should work as usual. Let's also have clean, so this will be like phonic clean, and it should remove all the stuff. So let's make clean, and now okay, yeah, as you might be able to see, we don't have gravity in our Tetris game, so that is what it is. Oh my god, wait, we just need a long one and it will be, well, nice. Okay, so now for now for the wasn't part. So as I was saying, I'm not sure if you can have structures in your functions like this. I think you can just have integers. So yeah, that's the first thing. And so let's see, because I was looking into this last time, was example, and so like a tutorial. I think this one. I mean, we can have more just to see. But yeah, I don't want to use the M script N or whatever. I would like to do it directly from C, if you know what I mean. Yeah, like these are, nope. Yeah, so I mean, we can check if we have, but like I know that it has. So yeah, grep wasm. So basically, this is how we have to compile the code. So first, we can try to do it for tetris.c, call this one tetris, and what we are gonna see is that it doesn't work because we have string.h. So as I said, we cannot really have functions from libc. So yeah, like one thing is that, well, the mem set is not really needed here. The mem copy is nice, but we can do it with a for loop. The only thing that's I guess pretty cool is the random. So maybe we can implement random in JavaScript and then inject it into the C code, like using linker symbols, something like that. That would be one idea. I mean, we can do the same for memcopy and memset, but like for memset, we just have to, when we create a structure, just set the board to 0 and that's enough. Okay, and for memcopy, as I said, we can use a for loop. So that's how we would make our thing compile. Let's make it compile first, and then we can go into it. Well, yeah, this is like an example of how to run this adder, like how to create your WebAssembly instance from JavaScript. And yeah, you can use like HTTP server from Python to serve it. But then here I saw that he's using WASM libc, and to be honest, I want to not use libc at all, so that would be more of a challenge. Instead of like using, I mean, we don't really need libc anyway, so what's the point? But yeah, see here he's using some arrays, so that means that we can, I mean, I guess use arrays, or even like for the structure though, right? So because in WASM you kind of have to manage your memory yourself in some way, right? So you have this heap base, and then see when he allocates memory, he just increases the pointer. So maybe we can even have structures if we do that, like keep the structure into this array, into the memory buffer. Mm, but I mean it's not really allocated, so that's one thing that I'm curious, like wasm c function structure, function struct. Okay, so I mean obviously, I mean, but that's a const struct, so okay, this is interesting because you need wait, what? Yeah, I was looking at the same thing. Well, I mean, I would be interested just in this thing, right? So this is how the assembly would look like. Let's see. Oh yeah, it was called what the this text thing. So I mean, yeah, the only question is how we can call this function from JavaScript when it has here a structure pointer. I guess we can try to use the heap base, like in this example, and in this heap base we can say, I mean, it would be easier to have the score first because it's an int, so it would take up 32 bits, and it would be, I guess, plus what, plus 4, right? And then after, I meant after another 4 would come the board. So we could actually pass that here. Okay, so that would be, I guess, one idea. But for now, let's first try to make this compile to WASM, and then we can worry about the other stuff, right? So, like I said, for memset, we cannot use. Okay, let's just delete these things. So instead of using memset, I guess we can use a for loop, right? So we just go through all the lines and set them to 0. Then for memcopy, again, we can just use a for loop. And okay, this is strange. Oh wait, what? Oh yeah, yeah, like this. So because this is the int, I forgot that I made it an int. I was like, what? But yeah, basically here we were copying into board from the address of piece, so we were interpreting piece as a byte array, basically. See, like this, and here it's an int, so we have to shift it each time by a byte, and like each iteration. And yeah, if we do and with 255, then it's gonna get only the byte. So yeah, I think that's how it works. Okay, let's include stdlib just to test it. Mhm. Because to be honest, for me it would have made sense here if this was board buffer minus I times 8. Let's maybe also print f the piece. We need the stdio just for this. Let's see, but we can't see it. Okay, so that's useless anyways. Well, another idea is just remove the J because L is the only different. This was the Z. And let's see if the shape will be null or not. Like that's the easiest way to do it, I guess. So yeah, see it's reversed. So I think it should like in spawn we need to start from the most significant byte. Here it starts from the least significant byte. Right, so here we should say board buffer minus I minus 1. I mean it looks the same, but wait, that's okay, I have no idea. Then it was right. Yeah, because this looks like a T. Well, I guess the issue actually was when I put the names probably. So this is stick, and I mean it goes to the let's say to the left. So maybe it's actually in the printing. Well, anyway, like this doesn't really matter, right? So we no longer have memcopy and that. So let's say here random int tetris rand int, and now we can define this thing here, and if we look in tetris .c, now it's fine, right? And if we go into main, here we can actually define int tetris rand int. It's just random, right? So now we have to keep in mind that we have to define this in the main of the next game. So yeah, here I was printing it in the reverse order. Yeah, like maybe if we do this thing, okay, yeah, even the controls now are reversed. So I I mean let's keep it like this because the controls makes more sense to have them yeah, in the reverse order. So and I mean the game is pretty much symmetrical, so you don't really see any differences. So yeah, let's let's make a small commit first. So main O and Tetris O should be ignored. Main O, Tetris O, create Tetris lib. Okay, and yeah, now if we run again this thing, it should, I think, well, how can we because it says undefined symbol, but we actually want it to maybe when it tries to export it. So we should say, okay, clang WL export symbol. I mean, it should be because there I was using export all, but well, I would say export symbol and then the name. Well, let's try to not export anything first. So this compiles, right? So then that means, wait a second, let's take this and let's work in the make file. You'll see the idea. Tetris.wasm. Well, I mean, it's, yeah, but I don't want export all, I want just export symbols. Can I say yeah, maybe something like this. So let's put Tetris. It's like Tetris tick and Tetris spawn. So and the last thing is no entry. Oh, and the no standard. That's already implied, I think. So yeah, and the basics. So yeah, I think maybe tetris.wasm. It's not export symbols. Maybe it's export symbol. Like if you don't want to export everything, how do you say that? Well, it's a WASM LD. So, oh, we can say undefined. Oh, we can actually allow undefined symbols. Probably that's better, like easier, I meant. export all. Interesting. So let's do export all. No entry, and let's also add allow undefined. Let's put a new line here. So let's say okay. Now it compiled with no issues. I mean, it's pretty interesting. So yeah, now the question is how are we gonna do the structure? That's the only thing that I'm not sure about. And wait, let's see because it's interesting. WASM to what? To see. Is it like an is it something that we have? WASM. Or do you have to install it? Yeah, I mean, we can just do this, I guess. See, here it does import env tetris randint, so it tries to get it from the environment. You'll see in the environment is this thing, I think. In this thing we can define the function. So then we have tetris init. This let's see, so tetris init is an export. Tetris init, here it says type 2. Type 2, what would this be, I guess? Well, it was easier to see in this one. So it was like the function, here it says param, and then result. Well, I guess type 2 might be, but because here it says function param i32, and then it's the same thing. How many locals? So yeah, it does some stuff. P0. Let's see if we can find P0. Oh, it's here. So this is like a thing. L1 is the stack pointer. L2 is set to 16, I guess. Yeah, pretty much no idea. But we can use the JavaScript from here to try and do stuff, right? So let's create an index.js file. Okay, and here we need to create the WebAssembly stuff. So I would rather, like, we need to create a function and like that. I would rather just use the callback version of this instantiate, and it's instantiate streaming basically. So I think here, oh, you can have the call to fetch. Oh, you can, yeah, that's interesting. You can actually fetch from an URL then. Well, doesn't matter. We can have here tetris.wasm. Then we have obj, and I guess that's it for error. So now let's create the index.html file, index.html. So it should be like a really simple whatever, like, can we have src? Yeah, why not? So we close the, whoa, we close the body like this, and I would say let's have here a div with the ID tetris or something. It wants to create a canvas and stuff. I mean, we can do that from the JavaScript code. So basically this is the thing, and now we can start HTTP server. Open up this thing. Okay, so we need to call fetch. So index.js. Here we call fetch, I guess. Oh, we have to restart this. Or do we? We can also just hard. So we also need something else in our instantiate. Let's see what we need. We need import object. Do we need like this thing with the env? Let's see. We need an object. Okay, let's do like hard refresh and see. Field env is not an object. Okay, so it looks like the same thing from here. That's good. Then let's say here env. Let's create our memory. I'm not even sure we need memory because uh, like we don't do any mallocs. So let's just create it like this. And look, this is really cool. It says that tetris randint is not a function. So we need to put it there, I guess. So this will be a function. Um, okay, so let's change. Let's go into tetris.c and let's change the random function to actually take in the piece count because I don't know how to do it without this tetris. So this should take in int max. And now if we go to main, we should int max and we modulo by max. Let's go in the make file and have a rule to make all all the stuff. So now we can just make, and yeah, like if we run the game, it should still work anyway. And now if we go in the JS file, we're gonna have a function. Let's create it like this. Max is gonna be oh, comma there. Okay, so now if we rerun this, it doesn't complain anymore about that. So that's pretty cool. Okay, now we have this thing, right? So if we look in Tetris H, we have some init, spawn, tick, basic stuff. I think it's better to look in main and try to copy this thing from main. Okay, the random works differently in JavaScript, so it's fine. We can actually have like callbacks for clicking on buttons, so that we don't need a separate thread. But we need to do the Tetris init thing. And how are we gonna do that? So obj.instance exports tetris init. Okay, let's call it like this and see what happens. Interesting. Let's console log. To be honest, I was expecting to get like an error. Okay, let's look at the tutorial then. So you say instance exports and then you call the function. Yeah. And for example, in this tutorial, it was like this input output. I think the function was somehow changed because here is input output and text length. Right, like here it doesn't have the length. So we also have the memory. Oh, we have it in obj instance exports with have memory. No, these are just the exports. But for example, how would we get the memory from obj? Like we have instance. It only has exports. So maybe it is in modular. Not really. Okay, then yeah, that's a good question. How do we access the memory? Let's look at this function again. So it gives us WebAssembly instantiated source. Okay, let's do access memory. Oh, nice. 4 years ago. No answer. Okay, let's see. Maybe there's an example. Yeah, I mean, I've noticed that. But this says that it contains all the exported functions. So, like, no memory then, or what? Well, you can create it like this too, but well, we can create it outside then. Wait a second. And then reuse it. So like let memory. Okay, we can do this thing, and now we can use it, right? So here, like, what does encode do in JavaScript? Oh, it's here, encode. Okay, that's interesting. So actually, we can just, I think we can say something like const, say tetris. This is like our structure. So this would, I think, initialize. I mean, this is the start of the memory, right? So, like in this example. Oh, yeah, I forgot about this. So we can actually have heap base. Let's call this view, and then let's have const tetris, or like this is the pointer to like tetris pointer would be okay. Let's also have let instance obj instance because it's instance dot exports. Do we have stack base? I mean, I saw stack base in here, but oh, stack pointer. Well, it's heap base, right? We just need a heap base, and I think that's it. We don't have multiple arguments, so only one. And then here in this encode function, I think, let's see what it does. So it has the memory, the base, and the thing. Right, so for goes through the string and then memory base. It puts, oh, that's really nice. Like we might need just a decode, right? Just the decode function. So let's see. Okay, so now it means that we can send the tetris pointer into here. We send the tetris pointer. Now let's I would say the decode function is what we need next, basically. Let's have here function decode tetris board, and we need the view and the tetris pointer. So basically we'll have the score equals 0. This will be 4 bytes as it knows, and let board, this will be an array, and if we look in tetris h, it is what's this, board height, it's 16 bytes, but it's just 16 bytes. 16 bytes. So now we have to iterate 4, and we get that, and then we just need to, I guess, do this. Is it enough? And then we return the score and the board. So this will be the decode. So then let's decode it, and let's try to console log it. Well, I mean console log the entire thing. I'm curious to see. So if we refresh this, it should be all zeros, right? Let's try to put something in score in tetris.c in here. Let's try to put like 69. We need to remake it. Well, that's disappointing. Let's try to put here I or something. Let's hopefully restart the server or something like this. It's still 0. wonder why. Like, doesn't it? I mean, it looks like it redoes the WASM thing. Wait, let's do again this thing. Where is the WASM? And like we should see in the init function 69 here. So it actually does something. Okay, let's console.log tetris pointer. Let's see the entire view, like just print everything. So this is the entire memory. Oh, it's really huge. Okay. So I don't know what the number signifies. So let's see. Oh, okay, so here we have a memory descriptor, but it doesn't say what initial and maximum mean. So let's try to do like maybe 8 or something, see if that is different. Tetris pointer. I mean, it's interesting if we do +1, what does it say? Oh, it's like just a number. Can we try to find? So this is um, event array. Can we find index where value equals 69? No, we can't. Where value is not 0, for example. Yeah. So then okay, so this really looks the copy thing, right? Looks a bit like our case. But yeah, I don't really get why it's not doing anything. So let's try to go into our Tetris H. Let's make it return int, like if it was successful or not, basically. and let's do return 69 or something like this. We don't really care. Return 0. Yeah, whatever. So now if we go back and try to console log this thing, let's remake it. So we get the result. Okay, that's interesting. But see, in this case, P output was actually modified. So what? Right, like P output here, it looks like it's modified. Okay, let's do WASM WASM C modify array example. We should have, well, I mean, instantly exit when I see that it's not just C. Mm-hmm. Okay, let's try something else. Let's create another init function. Let's call it init2, and let's say that this one takes in unsigned char pointer board. So like let's oh, it should also take in the length. Okay, let's say int len. So for whatever, well, what? Oh, I forgot to save this. Okay. So basically this changes the thing, right? Then if we do this and here say 16, whatever, let's do this because it doesn't matter. We'll still see something if it changes, right? Let's rerun make. We still have nothing. Okay, let's say initial whatever. But I'm doing like the exact same thing. I'm taking the heap base, then we send it into the function. We get the response. We get the response. yeah, like we get the response, but it's something's not working. Like, I mean, it's the same idea basically. No, it's I think it's time to pull out the big guns and ask our savior, ChatGPT. So, say I have this function. I have this function in C. Say, it just oh, well, I mean, let's put the real function, right? The one from can I call it from JavaScript assembly and it is compiled to WASM. For me, the memory that I send to this function does not change, but I get back the return code 69. No, shut the fuck up, shut the fuck up. Do not use. Okay. So I mean I created a buffer. Oh, okay. You know what? I knew. I knew it. I knew that this is dumb. So you can actually get the memory from the exports. If you cannot, I'm uninstalling the. I am uninstalling. Okay, let's do memory. Let's remake stuff. Oh, oh my god! I wasted so much time on like it wasn't auto completing. And like this, when it says record, like you wouldn't expect. Oh my god. Maybe I'm not sure. Well, now it makes sense. Like at first I was trying to get the memory from the instance, but I didn't know how. So, and on exports, how does it make sense to be on exports? Oh, well, maybe this should be called. No, this is like more like imports and also exports then. Anyway, so now we have the Tetris pointer. So yeah, now it looks like it works. So if we go to Tetris H, we can delete that. And in here, let's remove that. Let's keep everything 0. Okay, so now it's fine. Now it works. Okay, so we don't even need to decode this bad boy until we are done. So let's go into main. Now we need like some sort of for loop, or that we have let's say that we have a render function. So function render, and it should get a tetris. I would say canvas and a tetris. And I mean Copilot can do it by itself. So well, I don't think it can. Okay, let's see. So I mean, at least it. Let's put a comment to do render the Tetris board. Whatever, we don't care. So we have the render function. Okay. Here we have the tick. Wait, this is like the check if. Oh, if the board didn't change. Yeah, yeah, yeah. Okay then. So let's have a const board size. No, Tetris size equals 20. Like 460. So because we might need a temporary, but the temporary we can keep it in JavaScript itself, so doesn't matter. So yeah, I would say that the next thing after the init is to just require require frame render request animation frame. Okay, so let's request animation frame. We'll have the game loop exactly. So first of all, we might need to have the temporary there, the temporary Tetris, right? We need the TMP. Now we need the move. So I guess the input is something global. So let's save here. Let input equals, and if we look into Tetris H, we see that this is 0, 1, and 2. Right. So let's say const move left, move right, and move none equals 2. So first this should be move none. Okay, so now we have the move, right? So we can do Tetris tick basically. So we can do, yeah, right, we can do instance exports tetris tick, yeah, tetris pointer and the input. I mean the input here is just the move, I guess. So we get this thing. Now we get the tetris board. So we do the same thing. Tetris. Wait, I mean, is this efficient or not? Like we could just do it once here, temporary, and now we can just say at the end temporary equals tetris. Okay, so now we should compare the boards. So if tetris dot board equals dot board, this means that we can um, create a new piece. It's not really that we need to. So yeah, we also need let is game. Oh, let's make it global, or let's put it in game loop. Mm, not really. Let's leave it in there. Wait, but request animation frame. This. Oh yeah, like this would be more or less should be a function outside of here. So let's put game loop here, and this should call to game loop. Right. Okay, and that's not important. So yeah, it should be outside. So if the boards are the same, his game over should be equal to Tetris spawn. So yeah, I guess the game loop needs the instance. Can we somehow? Not really. I mean, does it really matter if we have the function here? So here should be instance exports Tetris spawn, and we pass it the Tetris pointer. So that's like one pass. Then we need to check if the game is over. So if is game over, I think we also have to just return, well, let's say else, let's render. Although we always render, and here it was actually Tetris. Oh, okay, let's create the canvas there. and if the game is not over, we request another frame. Perfect. So I think that's it for the render. We also have to create for input. So let's key down. Or A, it's move left. If it's D, it's move right. So let's use else if. Okay, let's console log this just to see if we get the. Okay, we don't have the canvas, so I forgot about that. So let's do canvas, and the ID should be tetris or something, and let's make it. The width should be 800 and the height should be 1200, and we're gonna use what, 100 by 100? I think so. Well, yeah, that's why I would actually call this game, and let's say document get element by ID game. So this is create element canvas. Width should be 800, 1200. Canvas.id equals tetris. Well, I mean, we have it global, but yeah, let's just use it. If it's global, why not? So because we don't, we just need this. Okay, everything is done. So yeah, it's just on key down. So let's do something, oh, something else. Let's say that, so if anything else, we set to move none. And after we get the input should become move none. So I think, well, yeah, I made input 0, but it's the same thing basically. Okay, so we make input to move none. Perfect. So block size will actually be 100. So now it's the interesting part. Let's see, showing the thing. So for let I equal to 4, I is less than 16, I plus plus. Okay, we get the let line equals tetris board. Wow, this is so annoying. We get a line. Okay, let's console log line. Let's see. Okay, that's good. 0. Anyway, so I don't remember how to make it also have an FPS or something. No, like const FPS equals 30, let's say. And how wait, what? Let's look request animation frame set FPS or something. Frame count, start animating. Well, I guess this would be the easiest way or something. So this is start animating. But see how it calls here. Oh, that's how you do it, yeah. Okay, so basically game loop. Let's do request animation frame. So FPS interval. Okay, let's have here some useful stuff. So it would be let FPS interval. Oh, it actually just copied start time. Then we have here we just do request animation frame. We then we calculate the now, the elapsed time, and then we have this. I have no idea why such a, and we subtract this thing, and now we can put the code here. So like it will run that it's whatever FPS, but it will run our code just when it gets the thing, when it passes the required time. So yeah, here we would need to stop, but that's funny, we can actually just restart. Yeah, sure, whatever, makes sense. I mean, it always looked weird to do this, but maybe. Let's see, so here let's console log tick just to see that it ticks. Even though we already console log here, so doesn't matter. And we don't need start time. Interesting. Yeah. So now if we okay, let's do 5 FPS just to see if it looks like it's much slower, so that's good. Okay, so now we have a better FPS. So let's console log line. So it's all zeros. That's strange. Or maybe we can compare the things like this. So how to compare two arrays? TMP board. Okay, let's try something. Let's go into console and say, what are these? Array. So it's an array created by doing push. So if we do 1, 2, 3, it's false. Okay, yeah. Let's see. Check that two arrays are equal JavaScript. Then that's Jesus. No, anyway, like yeah, that's. I mean, sure makes sense because they are like objects, but really, you can't have like a way to compare. It's even funnier that the guy used var anyway. So if the arrays are not, no, if the arrays are equal, that's when we have to check. You dummy dumb. So now we have random stuff. See, like, look, 24. The 24 is like, okay, that's cool. So let's no longer print tick. Let's not print the line. So now for let j equal 0. J is less than 8. That's the size of the board. Okay. Okay, that's nice that we can have. And I mean, let's say that we just do this. Oh, it's a bit too large. It's way too fast. Okay, let's make it slower. Let's do 5. Oh, and it's in the reverse order, but like it just worked. What? And yeah, controls are reversed, but holy, that's amazing. Like we just made this work. Nah, I just want a big one on the, and when you lose it just starts over. Okay, let's just do that when you lose, when it's game over, it also shows you how do you do it in game over score. Okay. So yeah, basically, I mean, okay, let's do block size const width equals 8, height equals 12, and here let's do well, width times block size and height times block size. So we can actually say, I don't know, 50. That's more like the size of the screen, right? And we have to, here we need to go from 8 to 0, like no, from 7 to 0. If we look in main, when we rendered the stuff, we went in the reverse order. So yeah, we have to go from left to right. Wait, what? The controls are still reversed though. Wait a second. It's strange, the controls are still reversed. Even though it's the same thing. Anyway. So buffer was 4. So let's just have some constants here because oh, actually let's make them like this because it's height times block size. So then here this is the buffer, this is height plus buffer, and yeah, here we have block size and stuff. Oh yeah, and this again is no, buffer, height plus buffer, and this is width minus 1. So like it's the same thing. I'm not sure why it's the reverse order. Oh, it's because here we should have width minus 1 plus j because printf starts from 0. Like if you imagine, printf starts from 0. So okay, we are missing some stuff, I think. Um, in which function was it? Like something broke because we changed this. Let's add some trusty console logs. Why not? Console log. Oh, we're so uh, decode tetris board. Okay, that works. So log game loop. This is called. That's good. Let's console log tetris and God. Sometimes copilot is useless. Okay. Whatever. Something. It printed it multiple times. So in render, is there something wrong? Oh, oh no, it's minus J. Yeah, yeah, it was minus J. Okay, now it's fine. Don't worry about the game. It's working. Yeah, and let's see now if we let it lose. We just have to wait a bit. Oh, he got a few points. Okay, yeah, and it also shows the score. So yeah, basically that was everything, right? Like I guess the only thing that made me like a bit, I didn't know a bit about was how to export the memory, like how to get the memory of the WebAssembly, like the thing. Then I guess this was pretty clear once I had the memory, and also how to call the functions. And yeah, something that I didn't really know if it's gonna work was decoding the structure. But since the structure was pretty simple, like 4 bytes and then 16 bytes, like it was aligned, let's say, on 32 bits because we built on 32 bits, right? So it's aligned there. Yeah, that made things simpler. So we did easily that. Also, yeah, I completely forgot how to do a game loop in JavaScript, but I mean, it is what it is. At least I knew how to search it. So yeah, I would say that yeah, it was pretty nice. So the main still works, the the simple game, and now I also have it in WASM. Well, it's funny because you can lose pieces and still go. But yeah, basically this was the project for these 2 days, trying to get Tetris into as few bits as possible. So even for WASM, if we check, we have like, well, I mean, it's not really true. We would have to look into this one. So we have just the score, which could be a character. because no one is gonna get more than 200 score. Let's be real. And this thing which is 16 bytes, so that's the entire memory we needed for the yeah, like you can see it here. We needed only 20 bytes to store the game, so that's pretty nice, and we can also see it. So yeah, see you next time.